Hello and welcome to my YouTube channel Coders Tech. This video deals with binary searching. So before starting guys, if you have not subscribed to my channel, subscribe it for more such useful videos. So the first thing you should know is binary searching works only on sorted array. So let's see the logical solution with explanation and the binary searching code. Hello guys, now we will see the logic behind binary searching. So the logic behind binary searching. First of all, before starting, you should know that binary searching can work only on a sorted array. So here you can see my array is sorted. So this is an array which is represented as on your screen, and here its index number. So this are index number which start with 0 and end at 12. So I have taken an array which stores 13 element. So now for binary searching, let our element to be searched be equal to the element to be searched should let it be equal to 77 for the first case. So for the first case our x is 77. Now for this we need a lower limit. So your lower limit will be equal to 0 for the first case, and your upper limit will be equal to 12, and then you will have your middle element. So middle element is the sum of lower limit plus upper limit, plus upper limit divided by 2. So for this case it is equal to 6. 12 plus 0 divided by 2 is 6. So now you can see at 6 you have a number which is 57. Now your 57 is less than 77. So this implies that all the element before it will be smaller. So you don't need to care about this because your element can never be present at the array with the part of the array which is smaller than your middle element. So coming to the part of the array which is greater than your middle element. So now it's here. So for this your upper limit remains same 12, but your lower limit will change to m plus 1 position. So it becomes 7, and your upper limit is 12, and your upper limit so your upper limit is equal to 12. So now your m will be equal to 9. Like 12 plus 7 is 19. So divided by 2 will be 9 as it is an integer number. So now at 9, let's see what element do we have. So at 9 we have 77. Yes. So within 2 comparison we were able to find out our element in a sorted array. Now let's take another example where our x is equal to 30. Now same process, your lower limit will be equal to 0, upper limit will be equal to 12, and your middle index number will be equal to 6 for the above example. So you find that at m is equal to 6 you have 57, which is greater than your 57 is greater than 30. So this means that you don't need this element now because your 30 can never lie in a part of array which is greater than your number. So now it's sure that it lies in this part of the array. So now you have to shift your upper limit. So now your upper limit will become m minus 1. So it will become 5 index number. So when your index number is 5, then your m will become 5 plus 0, that is equal to 5, divided by 2, that is equal to 2. So at the position 2, at the location 2, you have your number. So at the position 2, I have my number. Sorry, this one. So at the position 2, we have our number 30, and our x was also 30. So within 2 comparison, we were able to find out our 30. But if we go for linear searching, we have to compare and see all the element. So binary searching is best and time efficient if you go for the sorted array, and also if you go for binary searching, the number of comparison is less and hence the time taken will be less. So after this we will go and see its coding. So guys, now let's see the program for binary searching. So first of all, I have included the header file here. Then after header file, I have the function binary which inputs an array A, the size of the array, and the element I have to find. So X is the element I am interested to find. Now after that, I have three integers which I stated in the explanation, that those are L lower limit, U upper limit, and M is the middle element. So first of all, I have made lower limit is equal to 0 and upper limit is equal to size minus 1, that is n minus 1. Now I have used a while loop here in which I have run my case till L is less than equal U. So your lower limit should be less than equal U. If your lower limit becomes greater than your upper limit, that means that your element is not found. Then after that, I have given a condition in the while loop where my M is equal to L plus U by 2. So in this, I have given it in while loop because M changes multiple times in a program. Now you can see my first condition, which is if A of M is equal X. This implies that at the middle position you find your element. So I display it here that element was found at M plus 1 position. M plus 1 because in the index number is 0 and you find your element at 1, then it will display first position. Then I break the while loop. This is done because then after finding my element, I no longer require this while loop. Then after that, I have given a else if condition here. In this else if condition, if my element to be found is greater than my middle element, I don't require the smaller part of the array, so I discard it and make my lower limit equal to M plus 1. And in the else condition, where X is less than your center element, I have made my upper limit to be M minus 1. Then after that, in my int main, I made three integers and one integer array. So three integers is I, n and x. N is the size of the element, x is your element to be found, and a is your array. So the size of your array here, you can see is maximum size is 10. So user can enter any size from 1 to 10. Here I am taking element in ascending order as it works only on sorted array. Then the user enters it. Then I ask user to enter me a number to be searched. Here it searches, and hence I call after that I called a my binary function. So let's see how it runs. So let's run it and see. So here is my output box. So it states that enter the array size, which is maximum 10. So let me enter 5. Then after that, enter the element in ascending order. So let me enter 1, 2, 3, 4 and 5. Then after that, enter the element to search. So let me enter 4. So it displays that element is found at 4. So my element was found at 4. So now you can also give a statement in your binary function. If your element is not found, you can use flag and give it. So friend, I hope that you understood the concept of binary searching, its explanation, logic and the coding. Thank you. Mail at coderstechcoded@gmail.com for any queries. Thank you for watching. Like and share my video, subscribe my channel and keep coding.